ICIS is a high-power accelerator that fires high-energy protons into two targets to release neutrons for experiments. A world-leading centre for research, ICIS provides facilities for over 2,000 scientists from 30 countries visiting each year. The accelerator starts with the ICIS ion source, which creates negatively charged hydrogen ions made up of 2 electrons and 1 proton. These are then fed into the first of 3 accelerators. This accelerates the ions and focuses them, like an optical lens, for entry into the second accelerator, a LINAC. The LINAC accelerates the ions up to 35% of the speed of light. The ions are then transported to the third and final accelerator, a circular synchrotron. As they enter, the ions are stripped of their electrons by a thin foil, leaving the bare protons. The synchrotron is made up of 10 sections, each consisting of a bending magnet to keep the protons on their circular path and 5 focusing magnets. The total distance around the synchrotron is 163 meters. Electric fields provide the accelerating forces in ICIS. They also separate the protons into 2 bunches. As the proton beam is accelerated by the electric fields, the bending magnets need to become stronger and stronger to keep the beam on a circular orbit. The magnetic fields are over 10,000 times more powerful than the magnetic field on the surface of the Earth. After 12,000 revolutions of the synchrotron, the protons are now travelling at 84% of the speed of light. At this speed, they could travel 6 times around the Earth in just 1 second. The proton beam passes through a thin carbon target, producing muons for experiments before hitting the primary target to produce neutrons. Each proton produces about 20 neutrons. A separate beamline takes protons to the ICIS second target station. This target is optimized for low-energy neutrons, providing greater capacity at ICIS and opening up new areas of research. Neutron instruments are used like powerful microscopes to study the atoms in materials. Scientists can work out where atoms are and measure the forces between them. The whole ICIS cycle repeats 50 times every second, 24 hours a day. This requires a sophisticated controls system, so that everything can be managed by trained specialists. With both targets in use, 4 pairs of bunches go to the first target station, and 1 pair of bunches goes to the second target station. ICIS employs around 360 people to continually develop and maintain the accelerator and research instruments. Together they enable world-class researchers from across the globe to get the very best results. Based at the Rutherford Appleton Laboratory in Oxfordshire, ICIS and similar facilities such as Diamond Light Source are the driving force behind UK science. With plans for further instruments for the second target station and continuing research, development and investment, ICIS will continue to be at the forefront of UK science.